We have a circuit as shown in the picture. There are 4 resistors. All the resistance values are known. Also, the current passing through resistor 1 is known, so that's 6 amps. We'd like to calculate the current passing through R3 and the current passing through R4. First, let's calculate the potential difference across the terminals of resistor R1. So I labeled some potential points on the circuit. The left-hand side of R1 is point A, the right-hand side is point B, that's between R1 and R3. And the right-hand side of R3 is point C. Now we can see that both resistors R1 and R2 are in between the same potential points. So they have the same potential difference. But we have more information about R1. So let's start by calculating the potential difference between the terminals of R1. We are going to apply Ohm's law because this is a resistor. V1 equals R1 times I1, and numerically we get 24 volts for the potential difference across the terminals of R1. So because R2 is in between the same potential points, it has the same potential difference, 24 volts. Let's use that information to calculate the current passing through resistor R2. Applying Ohm's law on resistor R2, this time looking for the missing current I2, we find that I2 is equal to 4 amps. Now, let's take a look at our circuit again. We see that I1 and I2 join together at junction B, and together they make up I3, right? So I3 is equal to I1 plus I2. And when we do that calculation, we get I3 equals 10 amps. Now we need to calculate the current passing through the resistor R4. Can we actually calculate the potential difference across the terminals of R4? The answer is yes. If you think about it, this point here is also potential point A, right? Because from the top corner to this middle junction, there's nothing in between. It's just an empty wire. There's no circuit element in between, so it's the same potential point. That's A. This is also A until you get to the left-hand side of R4. Now on the right-hand side, I have C at the top right corner. This is also potential point C. This is also C, right? So then R4 is in between potential points A and C. On the top branch, I see that that's AB, from A to B plus from B to C, right? So the potential change from A to B, which is 24 volts right here, and the potential change from B to C, which we haven't calculated yet, but we can calculate using Ohm's law, is going to be equal to the potential change from A to C. So now let's go ahead and calculate the potential change across the terminals of R3, I'm going to call that V3, okay? And then V4, the potential difference across the terminals of R4 is going to be equal to V1 plus V3. In other words, potential from A to B plus potential from B to C. Applying Ohm's law on resistor 3, we get V3 equals 26 volts. Now we can calculate the total potential change all the way from point A to point C. And it's going to be again equal to potential change from A to B, which is 24 volts, plus the potential change from B to C, which is 26 volts. By the way, these are all decreases in potential. So these are all potential drops. Finally, let's apply Ohm's law on resistor R4. I4 is equal to V4 divided by R4, V4 being equal to V1 plus V3. Substituting the numerical values, we get I4 equals 10 amps. Note that we didn't have to know the value of the EMF voltage to answer this question. But now that we have calculated everything, we can tell what that EMF voltage is equal to. The battery is also in between potential points A and C, so the EMF voltage is equal to V4, which is 50 volts. 24 volts plus 26 volts.